and excited that AE Solar took the time to have us do a great presentation. We're going to be covering the Conext SW and the COM-box, which, by the way, if you place an order for Schneider Electric's SW inverter between July 5th and August 15th, you'll receive a free COM-box. So feel free to place an order, and that must be done through aeeexpress.com, and that discount's going to appear there both in the COM-box and the Conext SW inverter once they're added to the cart. So keep that in mind during this presentation. It really is a great way to bring two very fine products together. So we'll go ahead and step into the presentation. We'll be covering a few different things about the Conext SW, just an applications overview, exactly what the inverter is capable of doing, what we offer from Schneider Electric for that product, some of the neat advanced features, and we'll talk about how to apply those to real-world situations. Of course, it is a battery-based inverter, so we'll be talking a little bit about energy storage and how we can maximize a DOD, or depth of discharge, for that solution. And then when we get to the COM-box, we're talking about monitoring, being able to program that system both on-site and, for some advanced users, actually being able to do that remotely. We'll talk about a couple places where the Conext SW has already been installed through our case studies, and then just a final brief overview of what we've talked about. So again, as Hannah said, we're going to be covering questions at the very end, so please stay, and you may learn a few things along the way through that Q&A session. So as an overview of the system, the Conext SW really is a great price point for doing a few different types of applications, from a nice small off-grid solution where we only need, say, 3 to 6 kW or 4 to 8 kW of power, and then also for just a residential home who's asking for backup power, a great application. And then finally, for self-consumption, what we're talking about there is one feature, if you will, of the Conext SW, of course, is it is not a grid tie inverter. And so if you have locations where you're doing installs where it's going to be a bear, or maybe even impossible to do a grid tie system, doing something like self-consumption, where we're leveraging the solar inside the home to offset consumption without ever spinning the meter backwards, a great opportunity to use that in that situation. So it's just an overview of everything that the Conext SW is and offers. Of course, we can see here that we have the option with a single unit configuration or a stacked system configuration. My personal suggestion is to always make sure that you've got some headroom, if you will, to add a second Conext SW. Because the AC combiner distribution panel there at the bottom allows for the two inverters to be put together, if you ever think that you're going to be adding a second Conext SW to the solution, always make sure that you leave enough room above the first install so that you can actually add that second install. Of course, beyond just the Conext SW, we have a lot of neat additional products, including automatic generator start, which has a 3-wire start, with a lot of programming options. The standalone or integrated battery monitor, it can be just a monitor all by itself, or we can integrate it into the system to tell us exactly our state of charge. And then finally, we have two different ways of seeing the system, both with the control panel, which allows you to do programming setup through the system, and then the COM-box. And we're going to get a lot more into the COM-box, so I'll hold that off here for a few minutes. And then the MPPT 60 and the MPPT 80 are our two charge controller options. The MPPT 60 is a 150-volt open circuit voltage charge controller. Very, very popular kind of solution configuration when talking about the Conext SW. If you'd like to do high voltage strings, you can use the MPPT 80 and bring up to 600-volt solution into that. Of course, then we have kind of our balance of systems, if you will, with the DC distribution panel. This has our DC disconnects and where we land our big conductors that go down to the battery bank. And then, of course, our AC power distribution panel. The neat thing with that is that if it's just going to be a single Conext SW, we actually have slots there, the DIN mount slots, to perhaps use that even as our critical backup panel. So the circuits that we want to back up during a power outage or inject current on, for a self-consumption mode, there is slots still there inside that box to add. So you may not have to bring in yet another distribution panel. You can just use that AC power distribution panel to bring that all together. With the Conext SW, we offer a different size for different applications, both 24 volt, which is sort of a legacy item, and I'll talk a little bit about that, and 48 volt. A lot of the reasons that I kind of call the 24 volt solution a little bit of a legacy item is just simply because you get a lot more out of a charge controller if you can go to 48 volts to start with. Just simply because it's a 60 amp charge controller, 24 volts times 60 amps is a lot smaller number than 60 volts times 48. And so we really recommend starting out with that 48 volt solution. It gives you the best growth and as well as the most options for bringing in as much power as we can without bringing in additional charge controllers. So the Conext SW, it really is a simple design. Probably a lot of you are already familiar that the SW has been around for a long time. The Conext SW really is the father of the SW family, and we've been able to put this solution together so that we make it as easy as possible. As you guys know, panel prices have fallen, energy storage prices have remained roughly the same, and so things like soft costs, the amount of time and the amount of effort that it takes to actually put something up on the wall has suddenly become a real cost within the system, which usually we were able to, in the past, be able to absorb that into the cost of the panels because that was kind of the most expensive part of it. With the industrial design of the system, we make it as easy as possible to hang from a couple of studs. Monitoring can be seen straight from the front of the inverter for just basic configurations. You will really need a COM box or the CSW with monitoring to actually set the system up and program it. So you can't do it just by this. We do have some very easy ways of doing our conductor changes or connections there with number 3. And then finally, again, when we bring those two inverters together, or you consider that you may have to bring in a second inverter someday, make sure that that first install is a little bit lower so that you can just simply bring that and stack that second inverter above the first one. So one of the things that Schneider Electric offers is the Xanbus networking, which really makes it very, very easy to sort of daisy chain the system together from the control panel and the COM box, which is unique compared to a lot of other companies out there. You tend to get one or the other. But with this, you can get in front of you control and monitoring, but then as well you can get remote monitoring and setup so that things like setting up the generator start in this example or programming the solar charge controller can be done very, very easily. This is just done with standard Cat5 cable where you just simply plug one device into the other, and then those network terminators come in the box with the solution, so you're able to add those at the very end. Please don't forget those. It can create some issues with communications if you don't do that, but it makes it a very robust and independent system that you don't have to depend on anything else but really what you see here, maybe adding a battery monitor. But again, that's just daisy chaining another part into this solution. So if you need to add something later on, you're not tearing the whole thing apart. You're just simply adding another Cat5 cable and continuing that daisy chain idea. With the COM box, of course, we have a lot of different options of being able to see inside the system. We'll go into this a little bit more, but we can see daily summary plots. We can actually change the settings within the system. Probably one of the most important things with the COM box in particular is firmware upgrade. Both the MPPT 60 as well as the Conext SW, Schneider's always working towards perfection. And so you can actually set the system up that with just a simple thumb drive that's going to come in the boxes, you can actually upgrade the firmware. And we always recommend making sure that that's part of your install process is having that firmware ready so that you can go in and actually do the firmware updates, make sure that the product has the latest firmware. Some of the nice things with this system, of course, is with the data logging. We'll go a little bit more into that later into the presentation, but a lot of things that you can do. Data or the system dashboard is really something that at a glance we can see what that system's doing, both on-site very, very easily, and again, if you're an advanced user, you can set that system up to see it anywhere in the world. And we'll talk about Insight, which allows you to see that system and manage a lot of systems from just a single desktop display. So how does the communications actually work within this? And so we already talked a little bit about the Conext Insight. And with the CommBox, we have a local solution that we can see the whole system from anywhere in the world and be able to manage that with Insight so that we can have 20, 30, 50, 100 systems that we're managing from a single desktop and being able to actually see if there's any issues or errors. It makes for managing the the Schneider Electric product line from anywhere in the world very, very easy. And again, if you're an advanced user, you can actually set the system up so that if you did need to make a change even remotely, there's ways of going in and doing that with the CommBox. So here's just a great example of a simple system up in Canada. Again, you can see where we have a nice set of batteries and a couple of MPPT 60 charge controllers. And this system is a dual solution. So again, making sure that we leave a little bit of headroom so that we can add that second inverter later on is really, really important. So this is just a great example of a straightforward solution that's been very, very nicely done. So inside the inverter itself, this is just an overview of exactly what, if we were to lift the lid off and kind of look under the cover, if you will, of this system. We have four real major components within that. We have the AC and DC power board, which allows power to be converted as well as charge. And then we also have our AC interface board, which is where we're going to make those connections to both an AC input. It could be a generator. It could be the grid. And then, of course, we have our communications, which is allowing us to do Xanbus. If we want to do Modbus, we have our battery temperature sensor. All that stuff is done there. And again, the thing to point out about the Conext SW is it is not a battery or is not an export system. So this is really an ideal solution where we don't expect to ever have to sell power back, but we want to offset power. We want to support a generator. All this can be done within this solution with the Conext SW. So let's look at kind of three major ways of using it. We touched on this already, well worth going over again. So with the Conext SW, just as a straight backup system, this is probably the easiest and simplest solution, just simply because we're using the grid. There is no solar. We have a great little backup system, and the price point for a solution like this is fantastic because we can keep things simple. We can size those batteries out. We can use long-term float batteries as an example because we're assuming that the grid's going to be there most of the time, especially here in North America. If you have solutions that you're thinking of outside the country, choose the right storage solution for that. But a very simple way of bringing in when the power goes out that we have backup. And it may be that you end up sizing that system for 100% depth of discharge just simply because the grid only goes out 10 or 15 times a year, maybe. And so that's a very easy way of doing that. With the DC coupled system, of course, this is where we're getting into an off-grid application or a self-consumption application where we actually have solar charging the batteries and providing power to the home when necessary or offsetting those loads. The neat thing with the Conext SW is that we can actually do an AC coupled solution. And this is kind of an advanced thing because there's some things to know about this. But most simply put, because the Conext SW does do frequency shifting, any product out there that is already a grid-tied or grid-direct PV solution can use frequency shifting, like say in California, North America. Hawaii needs a little bit of caveats, but in short, this system can frequency shift once the batteries get to that bulk set point all the way up to 60.5 hertz and disconnect. So we're not accidentally overcharging batteries. So if you have customers out there who are saying, gosh, I have a grid-tied system. It's just pushing power back. I really wish I could do some charging when the power goes out. I have some concerns about that. The Conext SW really is the best way and the strongest price point for doing a 120-240 solution with this very, very easily. And again, we can just frequency shift out. We can do it incrementally so that the system isn't getting, if the grid tie inverter can accept 60.2 hertz, hey, I need to start removing or dithering the amount of power I'm putting out, great. Otherwise, we can just create an unqualified source for that grid tie inverter. So it just says, hey, it's at 60.5 hertz. That is now an unqualified source. I'm gonna stop pushing power. And then once the voltage falls down to a safe level for the batteries again, or we're out of that bulk voltage, then the inverter drops its frequency, and that grid tie inverter seizes the qualified source, requalifies it, and begins producing power again. So you kind of oscillate or modulate between that at that bulk voltage. So it's a really nice way of doing an AC coupled solution. So some of the neat features with the Conext SW is if the customer already has a simple 120 generator, we can take that 120 input and actually do a 120-240 output. Again, AC coupling with a smart charge, what that means is that we can make sure that that system is only buying power when the grid, when the grid is there and the batteries are low and we have a grid tie inverter that's pushing power. It senses that power is going through it and will only charge the batteries from the solar. So it makes a really nice support solution where we're never buying power from the grid, which can be one of those caveats that we could see now into the future. Dead battery charging, this is one where if perhaps you've gone to that 100% depth of discharge and the inverter hits its low battery cutout, we can actually, when an AC source comes in, either a generator or the grid comes back, we're not having to figure out, gosh, on a backup system, how do we get the system to turn back on again? Do I have to buy another part to just charge those batteries to get them to wake up? No. The neat thing with the Conext SW is that if the batteries get down to that low battery cutout, we're not inverting, and it sees an AC source, it will begin trickle charging that battery solution until we get above low battery cutout, and then that system turns on and does its full charging. We can also set up times through the programming using the COM box to do invert block, which means that we know that we're going to be away, or there's certain times of the day we just don't want the inverter on. We want to use it only for night lighting or something like that. We can actually set up different timers for when we buy power, when we inject current, or for this example with invert block, we're not inverting when, from 6 a.m. to 6 p.m., but then we want to start inverting to power lighting or something in the evening time. We have a very good surge capacity with these inverters. Again, we can bring those together, and we can do self-consumption based on that state of charge. So as the state of charge starts to drop, we can change how much power we're injecting into that. And then finally, all of the Conext SW and the whole Schneider product line is already lithium-ion ready. So you can bring a lithium-ion solution if that's kind of the hot thing and you want to do that. Definitely can do it with both the Conext SW and kind of the big brother, the XW Plus. So we are ready for any lithium solution. The really neat thing that I like about the Conext SW in particular is it really gives you that option to bring in that 120 source and provide 120-240 on its output. So this is unique to the system because it already has that balance transformer inside. Just simply land the 120 onto the L1 input of the Conext SW, and on the end have 120-240. So you don't need that 240 generator. There's not a new investment if the customer has, say, just a simple 120 AC input because they don't have a 120 AC generator. Instead, we can still use that system without having to pull that old generator out, and it doesn't require that auto former, which can add, again, more cost of solution. So this really is one of the best and the sweetest price points that we have for this type of solution. With Smart Charge, we touched on it. Worth going and talking about different regions within the world, and there may be some other regions around where when we are AC coupled, we are only going to charge from the PV source. So the grid may be there, but if it's 3 in the morning and the batteries have been, dropped down a little bit, we're not going to be buying power from the grid. We're instead going to wait till the sun comes up and then start buying power from the PV source first. And then once the batteries are taken care of, then the charging dithers, we're in an absorb cycle. We're only drawing a few amps to charge the batteries. Any excess amps from the PV system, and it doesn't have to be a Schneider one, it can be an existing grid-tied PV system, is then just going to start pushing power out to the grid. And so we're never buying power from that AC source. So a really nice way of making sure that, and there are those regulations that are out there, to not buy power from that AC source. Last thing you want to do is be buying power during a peak time just to charge the batteries. This is a great way to make sure that we're not doing that. So AC or DC coupled, AC and DC coupling we can do actually at the same time. So we can actually allow power to pass through it and go out to the grid, but then also take care and charge those batteries at the same time. So it could be that, again, an existing PV grid tie system, somebody says, gosh, I want to bring a battery bank in and I want it big. But just for simplicity's sake, let's go ahead and bring in a DC coupled system as well. So we're going to bring in PV through an MPPT 60 or an MPPT 80 charge control. We can charge those batteries, and those batteries will get taken care of. And so we can be connected to the grid or generator and do the AC coupling and do DC coupling at the same time. So a very versatile product that allows us to do just about everything that a customer base would ask for with this solution. But again, if we do a solution like this and we have a grid-tied solution pushing power back, one thing to note is that, of course, the SW is not a grid-tied inverter. So the DC solution portion isn't going to add to the selling power of the output of this total solution. The grid-tied system will, just not the CSW. When we talk about enhanced grid support, what we're really talking about in this crazy graph here is that we're able to inject power from the battery bank to offset how much we're consuming based on how much MPPT we're putting out. So this means that we're not dipping into the batteries necessarily. We can set it up so that the batteries are part of the offset solution, but we can also make sure, especially if we want to make sure that if a power outage occurs, we don't find ourselves with our batteries in a lower state of charge, we can make sure that we're injecting power. We can see here that the AC power support comes up as the batteries are being taken care of. So as we know from absorb, the amount of current that's going into those batteries starts to drop off, so that then allows us to start injecting that extra current into the AC output of that inverter. So in essence, we begin self-consumption a little bit sooner, which is going to maximize the solution and be able to take care of that solution to meet the needs. So the example is, of course, I want to reduce my consumption, and I want to reduce my consumption during the overnight hours. Once the sun comes up, the batteries start getting taken care of, and once the batteries start reaching that absorb voltage and the current starts dropping off, what are we going to do with that extra power? We're actually going to start taking that power and pushing it out of the AC the AC output of the CSW and start offsetting the amount of consumption while the batteries are completing their charge. Once the battery is completing their charge, we can see here that the AC support power nearly matches here at float the output of the total system. So very cool way to make sure that the batteries get taken care of and we're offsetting as much as possible. So really maximizing the amount of offset and maximizing the PV array that's been installed on the home. Dead battery charging, a lot of customers can find themselves in a situation where they've unfortunately discharged their batteries, not only past 50% state of charge, which is kind of the recommended, but an extended power outage or an issue with a generator has resulted in the batteries going to too low of a level for the inverter to support that anymore. So what do? Most people want to fire up a generator, but if the inverter does not have a dead battery charger, and there's a lot of competitors out there that don't have this, then suddenly you're MacGyvering your way through with jumper cables on batteries. What can we do to get this system charged up again? Instead, we just start the generator or find an AC source and begin charging those batteries and getting that system up. So again, with a backup solution, if the customer had a 2-day power outage and we sized the system for 36 hours, and unfortunately we've gotten to that point where the lights have gone out because we've hit low battery cutout, when that AC source returns, the inverter is going to actually start taking some power and slowly charging those batteries, getting it above that low battery cutout, and then begin charging those batteries at the full output of the CSW. So a really nice insurance policy of not having to roll a truck just to take care of a customer because they call you and say, the lights are out and, you know, I think our batteries are dead. That's okay. I apologize if that happened, but once the grid comes back, that system will start charging that power system again. Or if you have a generator and you got to run down and put some gas into it, you can start charging that system again. Inverter block, we've talked a little bit about this with being able to set up a lot of different timers for when we're going to be using the system or we're going to be charging the system. So there's a few different clocks inside that we can set up. Probably the easiest way is through the COM box, which is really nice that AE is providing the CSW along with the COM box together as a discounted package, because setting up these timers and things like that through the display and the of just a laptop, we can see the system and set those timers up perfectly and lay them out in a logical way and see them. So if it's going to be for a kind of a non-residential solution like street lighting, again, that example, we can set it up so that we're not providing power to that lighting until we know that the sun goes down. So that's kind of that 6 a.m. to 9 p.m. timer. We're just not inverting. And then once 9 p.m. rolls around, we start providing power. Batteries have been charged all day long, and we're ready to go all the way through to that, that 6 a.m. with inverting and providing power. So it gives you a lot of control and opens up opportunities for some creative solutions. Frequency shifting, touched on this already, went into quite a bit of depth on it actually, so just touch on it again, that once we have the system beginning its charge, what's going to happen is we're going to start doing a frequency shift. So once we hit bulk, we can see here that our frequency is actually starting to shift to 60.2 hertz. The really neat thing about this is not only is it going to take care of itself during a bulk charge, it will continue frequency shifting based on where it's charging. So if it's in float, we're not going to continuously start bringing those batteries up to bulk all day long during an extended power outage, or if it's an AC coupled solution. Instead, we know our target. We know our target voltage, and we're going to frequency shift based on those. You can also use a dump load to help shift that out as well if you don't have the AC coupling. So we can set that system up not only to do frequency shifting, but push come to shove, we can just simply allow to do a dump load, or we can actually run a small relay and just open the contactor between the AC coupled solution and the battery-based solution, and it just blacks it out essentially. So some neat ways to do that. One of the things that I like about Schneider Electric and working is that knowing how much testing we do, and again, always going towards perfection. And so when we talk about understanding how these systems are going to survive, as you guys know, the Schneider Electric product line, there's a lot of legacy products out there and remain out there. Why is that? Because we've done a lot of accelerated life testing to make sure that this system can last and survive in some of these crazy places that we end up putting it in. If it's from the high desert to the tip of Florida, and we have high humidity and salt air, we've done testing for all these systems to make sure that these solutions are going to last and maintain themselves well beyond the expectations of the customer, and we'll have happy people for many, many years. So one of the things that I personally like to talk about, especially when we get into consuming battery power, and if you guys were at the AE conference, we touched on this already, worth talking about again, because this is such an important part of using a battery-based inverter is our batteries. A lot of the times we end up sizing that system out for 50% depth of discharge. I'm actually recommending that we do a system that is actually twice as large. Why is that? Because the number of cycles that we get out of 50% depth of discharge in this example is about 2,000 cycles. If we can keep it between 25 and 30%, which really is the sweet spot for energy storage, we actually get more out of that system. So let's look at just a quick example of what I'm talking about for when we talk about state of charge. So for lead acid, of course, we always talk about make sure that you don't go below 50% depth of discharge. For lithium ion, of course, there is a lot of options to discharge beyond that, and the battery management system will, of course, help make sure that we're here. But really, between these 2 points, we can use the heck out of the lithium ion, and so depending on the solution, that can be a very cost-effective way of bringing in solution. But still, with the lead acid, of course, we don't want to do this amount. We don't want to do 75% or 100% state of charge, unless we're talking about something like a residential system where we only lose power a handful of times. We could arguably do a 75% state of, or depth of discharge out of that system because, okay, we only get 1,000 cycles, but if we do the math on the number of predicted cycles that we're losing, we don't have to size it to 50%. We can size it to what's the age, what age is the battery going to be aged out of the solution? 10 years, maybe 12 years? Okay, well, if we only lose power 3 times a year, then we can size the system out with a deeper depth of discharge, and it keeps the system much more cost effective than if we always just size for 50%, even if those batteries are going to sit on float 99.9% of the time. So let's look at how that cost-effective solution works when we talk about depth of discharge. So we can see here 10%, 25, 50, 75, and 100. If we notice here at 25% depth of discharge, again, this is that sweet spot. This is the cost per kilowatt hour if we were to bring in a large storage solution so that we're not doing 50% depth of discharge, but somewhere around 25 to 30% depth of discharge. The cost per kilowatt hour when we're cycling those batteries is going to be lower. So if we sized it out at 50% depth of discharge, what does it cost to pull power out of that solution? About 20.8 cents per kilowatt hour. If we doubled the size of the battery bank, this is kind of that sweet spot. This is where we have, it's 3.2 cents per kilowatt hour less expensive to bring in a larger solution. So start with a larger solution. It gives a lot more backup power if something were to go wrong, or we had an extended power outage, or for an off-grid solution, which really is the focus of this example, it gives us a bigger insurance policy for a longer low installation period, because then we're sizing for 25% average depth of discharge, whereas 50%, then we're starting to dip deeply into the low cycle portion if we went down to, say, 75% depth of discharge. So that's the inverters and batteries. So let's look at a little bit of what the monitoring offers through Schneider Electric, both on-site as well as with in-site. So on-site, in-site. So let me show you. So once we get the install done and we've set up our programming, how do we make sure that the system's working? We have some great ways of doing that with our daily summary charts. We can just quickly and easily look through that system. The customer can look at a main face page to understand what's going on at any given moment. If we have some issues with the system, we're able to look at those the daily summary charts, not only for the day, but we can do it for the week, the month, a year, and the whole life of the system. So a lot of options for seeing what the system is going to be doing, both with battery consumption, make sure that our AC coupling has been set up correctly, that we are injecting current, especially if we're doing something like self-consumption. Make sure that we have all those settings set up correctly, and monitoring and being able to see those daily summaries really is the best way to see that system. So when we look at the system, when we look at the solution, this is the internal page that is available through the Conext, through the ComBox. And so when we see the system, we see here down on the right-hand side, this is kind of just the front page to the system. This is what we can see very easily, where power is flowing back and forth. Once it's set up inside of a home or a solution, just simply save that IP address and onto the favorite browser of a customer, and they can simply click and look at the system. If you don't want them to have this kind of advanced view and they do have an internet connection, strongly suggest Insight, and we'll talk about that here in a couple of minutes. The neat thing with the Conext box is that, or the Conext ComBox, is that we can actually have the system email you, the installer, to see what's going on with that system. We can make note of what's going on within that solution. We can always check the battery voltage, and we can also look at what events have caused certain issues if we get that email. So one thing that I always recommend, of course, is do a couple practice power outages with the customer just to see how they're going to behave within that system. Make sure that we didn't miss any circuits that are important to them. I had that issue with me. I have a backup solution, and I had a power outage and realized that, oh, we missed a circuit down in the basement, the whole basement. And so during a power outage, I was out there putting in a new breaker on the output and redoing that. So my fault. So make sure that you practice that before the real event. Make sure that everything's covered. When we look at the summary sheet and we kind of dig into it, we can see here this is a pretty advanced system. We got a lot of inverters going on here, but that's the neat thing about this solution is that it is very versatile, from a single inverter all the way up to 12 in this example. Don't ask about that because it's a little bit of an advanced solution, but really what we're talking about is being able to see everything on the solution all at once, understanding where the loads are going, how much PV we're bringing into this solution, and exactly where the batteries are at. And that number is interesting, but that's okay. So that is the internal interface that the ComBox offers right out of the box. Again, with the ComBox, we can do things like firmware updates, which I highly recommend doing from the get-go. Make sure that you have that loaded, especially if you're going to be going out to a site that's remote and you don't have internet connection. One of the things you need to do if you know you're going to be doing a job with the CSW, go to the Schneider Electric website and download and make sure that you have those files on hand, ready to go with your laptop so that you can update the firmware and set it up. So at the very least, the best thing about this solution and the AE is offering this great product along with monitoring and the ComBox is that you're going to need to do a firmware update anyway to make sure that everything's up to date, and having those come together as a product and as a solution really is a match made in heaven. So I'm excited that they're being able to do that with you guys. So we have the ComBox and we have a local view, but we also again have Insight, which allows us to monitor not only one site, but many, many sites. So we can see here, what's probably going to happen is if you are a traveling installer, you might see a big view of the United States, but more likely you're going to see a bunch of systems very local to yourself that you can see. Now, if we look very carefully and we're looking around here, we can see a couple of differences between the systems. Here we have a grid-tied decentralized site there in California off to the left. But then we also have battery-based systems, and we can see this very, very easily because there's a little battery symbol there. As well, we can see that one of the systems is not behaving. And why do we know that? Because it's a different color. So in the morning, we get up, we get our coffee, we go to Conext Insight, and because we've done these CSW installs with the COM box, we don't have to do much beyond open up a web page and check to see if any systems are misbehaving, just simply because we can very easily see that the color has changed. Something's going on with that system. And if we were to double click into any one of these, we actually jump into the site. So here is an example of if we were to double click onto one of those tiles, and this is a battery-based solution, we're able to see what exactly that system's doing, and we can actually change how these numbers are being seen from today, how is it doing this week, the month, the year, the lifetime. So very easy way to look at the total system very, very quickly. And then we can also jump into some graphing and understand exactly what's going on inside this site. Let's take a look at that. So here we can see exactly how much load we have and how much PV input we have. This is probably the best way to understand, is the system's output matching the loads? And if it's not, then we need to start looking at coming up with a solution. So this is going to be a good indicator if our loads are not matching our PV, and we start looking at this over a day or a week or a month, and we're noticing that we're always running a deficit. That deficit can result in harm to the battery. So a great way to look at the system, a great way to understand, is our loads matching our solar, and are we getting enough into that solution to actually charge it up during the daytime? So if we understand, so we've looked at what the PV and the loads are, but now let's look to see how those batteries are doing. So with the battery charge, we can see that it is kind of moving around, which is what we're going to see in an off-grid system as loads come on and go off. Well pumps and things like that are going to be moving around, and hopefully we have some PV input that's going to match. In this case, again, we don't quite have enough PV input, and we can see here that our batteries are starting to drop off. So we need to make sure that we're using a generator, which is what we're seeing here, that the generator along with the PV are working in conjunction to take care of those batteries. So again, a great way for us to choose what we want to see here. So we can choose what a daily summary, plus we want to see what our bank totals are and what our charging is. So we can see and choose what we want to see through the Conext Insight solution. And again, with the COM box, makes a great matching to understand and monitor and take care of those systems that we're responsible for. For our daily summary, we can see here with a generator, if we want to understand exactly how much the generator is putting in, is it meeting our expectations, is the generator running too much, we can select exactly how we want to see the solution. And understand if, if we're at 600 hours, we need to do some maintenance on that generator. A great way to see that total system and really understand how the different portions are performing and be able to graph that out how we want to see it. So case studies, these are just some neat examples of how systems are being used right now. And we'll just jump into a couple of those solutions. Nice, good-looking installs and just some things that actually apply to the real world. So here we have a nice little off-grid commercial site in California. And again, we have a really nice stacked solution with a couple of CSWs, and we also have some MPPT 60 charge controllers and a generator for this solution. So just a really nice power panel, as you can see it there installed. Probably the thing that I like to point out is the lights. It's not a bad idea to wire in some lights very, very close to the solution so that during a power outage, you have some options for being able to see what you're doing. As Murphy's Law states, if something can go wrong, it will. Making sure that you have some really good lighting in and around the solution not only confirms that the AC output's working without yelling, hey, is it working, between the power shed and the home, but you can also double check yourself with some lighting. And of course, having good lighting also means good safety as well. Make sure that that system you're able to see it at night. Oh, I'm not sure what that is. So Here's another nice example of off-grid living in Romania. So this is a European CSW where they've done some of their own balance of systems. So you can see here they just decided to wire the AC out. So they didn't use the lower balance of system solution. But what they have is, again, a really nice, simple single inverter with a pair of 80 amp charge controllers. We can see here that they have kind of two different angles, and so something to consider. I would venture to guess, yeah, this is a 24-volt system. So these 9 panels and these 9 panels, each one's going to its own charge controller. Because again, if we go with the 24-volt solution, we're only able to put half as much solar onto each 60 amp charge controller, whereas if this was a 48-volt solution, you could potentially put this many panels onto a single charge controller. So I am a big advocate of going with the 48-volt system to start out with, just simply because it allows you to maximize inexpensive PV into a single charge controller, and in a cost-competitive environment, this can be a great way to make sure that we're not adding any additional cost that's unnecessary. So a final overview of what we've talked about. Again, the Conext SW along with the CommBox is one of the best values in the marketplace. With the Conext SW, we have some great surge capacity as well as really, really good charge efficiency. We have a unique set of features that allow us to really get the best ROI for a broad range of applications. If it's from just a simple backup solution to AC coupling to a self-consumption solution without having to sell power back to the grid, the Conext SW really maximizes all of that. And we're able to do that because Schneider Electric spent a great deal of time testing and making sure that the firmware, the electronics are well tested, and we make sure that we're doing this with the CommBox so that we're able to see that system from anywhere in the world. So again, please consider Conext SW. The best place to do that is if you guys place that order again, which for the Schneider Electric Conext SW, again between July 5th and August 15th of this year, you'll receive that free CommBox. You just have to go to the aeeexpress.com website, and when you put both of those into your cart, you'll see that discount automatically apply. So we make it super easy, and we want to thank AEE Solar for doing this with us and providing this great pairing of two products for you guys. If you do have any questions that linger beyond the question and answer time, you can feel free to email me. Or, again, AEE has a great support group, and you can order through the website, aeeexpress.com, or if you need some questions answered, sales support at AEE Solar is a great way to get a hold of them as well if you have any follow-up questions. So that's what I have. We'll go ahead and get into some of the questions and answers, so I'll hand it over to Hannah.
All right, great. Thanks, John. We'll dive right into our questions here. We've got a few minutes to go through some. John, our first question here, what is the difference between the SW and the XW Plus NA?
There are two primary differences between those two products and one minor one. So the two main differences is that the power output of the XW Plus is quite a bit more, 6,800 watts versus 4,000 watts. The other major difference between the two products is that the XW Plus is a grid tie inverter, so it can sell power back to the grid as well as do off-grid and things like that, whereas the Conext SW is really not, it is not a grid tie solution. The one minor difference is that the Conext SW can take a single phase input and provide 240, whereas the XW Plus does require a 240 input. So if you only had a 120 generator to the XW Plus, it would require the extra cost associated with bringing in an autoformer to create that 240.
All right, great. Thanks, John. The next question we have, is the SW compatible with the Acqueon saltwater battery?
Yes. So the really nice thing with the Conext SW, and you want to make sure again that you have the latest firmware, is that we have very broad programming windows that we can set the system up. And so the Acqueon batteries like to go very, very low, and especially when they get under a heavy load, the voltage tends to taper off very quickly. You can set the low battery cutout very, very low on the Conext SW. So we opened up those windows to allow you to be as compatible as possible with the battery technologies, and with the Acqueons, absolutely, you can set that system up using those batteries.
Great, thank you. The next question we have, can the inverter handle a 240-volt input from a generator?
Yes, yep. There is an L1, an L2, and a neutral input, so you can do a regular 120-240 generator, and then the inverter will pass that 120-240 on out to the load. So yes, either way, single phase or split phase 120-240, you can do that. But you do need the neutral if you need to do a 120-240 solution.
All right. And the next question, what is the warranty period of the inverters? Does Schneider sell an extended warranty?
Unfortunately, Schneider doesn't do an extended warranty, say for California, where they, in some cases, want a 10-year warranty. We are currently not offering that.
All right. And can you talk about demand peak shaving and how to use the CSW and CXW Plus to do that?
Yeah, so through the programming of the inverter, we can actually set up how much current we're going to be injecting into the solution, or we can base it upon, if we have a complete Schneider Electric solution with the charge controllers, we can inject current based on PV available. So we have two different options. We can choose to dip into the batteries, where we're just always injecting current, say 5 amps or 10 amps on the AC side, and we can program that up. Or we can set the system up to kind of base that on battery voltage and make sure that the batteries are always taken care of, and any extra power being produced by the PV array will then get transitioned or converted onto the AC output. So if you have good solar, then you have good load support. If you have if you choose the other programming, then we're always going to be leveraging the batteries to a certain set point to be injecting current on. And most people, that's what usually people want, is to have that system so that even if it's not a great installation day, we can do that. But again, if it's an AC source, it's an AC source. So that same idea that we're using for generators to do load support for generators is the same basic idea for doing load support for the for an AC input like the grid.
All right, and going back to our warranty question, what is the standard warranty currently?
I believe it is 2 years for the CSW. You definitely want to check with the Schneider Electric website and check the warranty, and we have a warranty statement, so definitely check there. But I believe it's 2 years for the CSW.
All right. And you had a slide stating the product worked for Android or PC devices. Can it also work with Mac and iPad devices?
Yeah, because it's an H page, as long as you have a browser open, that's essentially how you see both the CommBox as well as Insight. So there's no compatibility issues because it's not an app per se, it's just a website, both internal to the CommBox and external through Insight. So any phone, tablet, PC, Mac, Apple product, you'll be able to see that system both internally with the CommBox as well as externally with the Insight.
All right. And for stage 3 charging via frequency shift, must one use a Schneider brand unit for the grid tie type inverter?
No. So there's kind of two different ways to look at this. There are some other inverters that are out there, grid tie inverters, that will reduce their current output based on frequency shift. It's usually done in 20% increments. So between 60 and 60.5 hertz, that's 5 notches, that's 20%. So as the frequency shift occurs from 60 to 60.1, that tells the grid tie inverter, hey, I need to reduce from 100% to 80%, and then so on. If the grid tie inverter is not compatible with that idea, and there's new firmwares coming out for different inverter products, so definitely check if you have a customer asking for something like this, that they want battery backup, but they also want to charge batteries from the PV array, to see if that product's compatible. If it is not, then during a power outage, the Conext SW is going to get power pushed onto it from the grid tie inverter, and it's going to begin frequency shifting from 60 to 60.5 hertz. Well, with UL 1541, to be compliant, it has to fall within that window. So once the voltage shifts beyond 60.5 hertz, what's going to happen to that grid tie inverter? It's going to say, hey, that's outside of my my parameters. So that's no longer a qualified AC source, so it's going to stop selling power. Once the battery voltage starts to drop back down again, then what's going to happen is the Conext SW is going to frequency shift from 60.5 or 60.6 hertz back down. It will become again a qualified source where that grid tie inverter is going to say, hey, that system's now, or that frequency and voltage is correct. I'm going to start qualifying that, wait my 5 minutes, and then begin selling power back again. So absolutely compatible with, here in North America, pretty much any grid tie inverter, even single unit inverters, something that goes onto the back of the PV panel. You'll be able to use this because we're just creating a qualifying or disqualifying AC source during AC coupling.
All right, thanks for the explanation. The next question we have, will the SW work with existing N-phase microinverters for self-supply or backup with Hawaii's current inverter rules?
That one's a little bit more sticky because of the ride-through. The frequency shifting requires slightly different programming within the system. So remember, the way we decide, the way the inverter decides how to frequency shift is based on our voltage charge setting. So if we have something like in Hawaii where we're riding through to 61 hertz, then yes, the Conext SW will continue frequency shifting beyond 60.5 hertz to continue to kick that system out. But because of ride-through, it's not highly recommended because now we're reducing our bulk voltage and other voltages to kind of kludgy to trick that system into disconnecting. What I would suggest in that case is not use frequency shifting, but simply use the aux port on the inverter itself so that when we get to that set point, say it's on a 48 volt system, we get to 58 volts, yep, batteries are full, then what we can do with that system is just simply open a contactor. The grid tie inverters no longer see an AC source, they have nothing to sell to, and then we can set up a delay timer so that once that battery voltage drops back down, then we close that contactor. So for Hawaii, do not recommend using frequency shifting, but instead just using a contactor to just simply open the connection from the grid tie inverter to the Conext SW. It doesn't see an AC source, and so it disconnects.
All right, thank you. The next question we have, can the system work with other charge controllers? For instance, a wind turbine with a built-in battery charge controller?
depending on the application, you know, the inverter sees the batteries as a gas tank. So it will provide power and things like that. You may be missing out on, especially like a load support function. That system will do load support, but it will not have the fine finesse of saying being connected through Xanbus with the MPPT 60 or MPPT 80 charge controller. So you don't get the finesse of it. But yeah, absolutely, a wind turbine is going to push power onto those batteries, and the Conext SW will allow that to charge as well as inject current. It just, again, it won't be as, no, use finesse. It won't have as much finesse as a charge controller from Schneider Electric.
Great, thanks, John. And we'll get through a couple more questions, but I just want to remind everyone that if you complete that survey, that will pop up at the end of the webinar. So when you exit, it will pop up in a new window. If you could complete that survey, it's only a couple of questions, I'll send you a copy of the slides. So don't forget to do that, and feel free to email me if you miss out on the survey or you're not sure where to find that. All right, and we'll get to our next question. Is the SW switchable to 50 hertz?
It is 50, 60 hertz switchable. So if you're going in places where it's like 120, 240, 50 hertz, that is an option to change the frequencies. Again, make sure that you have the latest firmware. If it's a European voltage 230, 50 hertz, or IEC, I should say, then yeah, you can switch between 50 or 60 hertz, and just choosing if you need 230, which is IEC, or kind of the North American voltage 120, 240, absolutely do 50 or 60 hertz.
All right, we'll move on to our final question. The Schneider app notes that for AC coupling states it does not support lithium-ion batteries. Is that accurate?
That's a trick question. Yes and no. So there are some partners with Schneider Electric who have set their system up to communicate from the battery management system to the Schneider Electric product line. And that's really where the magic is. So if we are doing AC coupling with a lithium-ion solution, absolutely doable. The concern is that we have basically an unregulated charge coming from the AC coupled solution onto the battery management system. If it doesn't like the current and it can't tell the inverter, hey, frequency shift, slow down, stop, we're getting too much, what can happen is that the battery management system could kick into a fail-safe mode, which means the house goes dark because it's opened its internal contactor between the CSW and the lithium-ion battery bank. So definitely make sure that you understand and talk to the manufacturer about what the parameters are when AC coupling using lithium. Absolutely doable. It just comes with so many caveats, and we actually are updating that white paper to kind of say it in a nicer way. But if you're unsure of yourself on lithium-ion with AC coupling, talk to the battery manufacturer, and maybe reach out to Schneider Electric if you have any further questions. But as of right now, unless there's a partnership where there's communication between the battery management system and the Schneider Electric product, either through Modbus, then it's not really recommended, but definitely doable.
All right, well, thanks so much, John, for answering all of our questions, and thank you, everyone, for submitting those awesome questions. That concludes the presentation for today. John, do you want to make any final comments?
No, I again want to thank AE Solar for putting this presentation on. I love talking to you guys, and really good questions. Again, make sure that you guys are placing that order through AEE Express, and when you put the CSW along with the COMBOX into your cart, you will see that discount. So hopefully we'll see a lot more systems on Insight, and I think you guys will be very, very happy with what the COMBOX offers in conjunction with the Conext SW. So again, thanks, Hannah. I appreciate it so much, and look forward to seeing you guys, if nothing else, at the AE conference next year.